All right, so far in this chapter, we've talked about ratios, proportions, indirect measurement, cross multiplying, and all that stuff. So what we're going to do today is we're actually going to introduce a new concept. This concept is called trigonometry. I'm sure you guys have all heard of what trigonometry is, but basically what trigonometry is that it has to do with triangles and the makeups of the triangles. So first, before we do this, we need to actually point out names of the triangles that we're working with. The first is, as we learned with the Pythagorean theorem in the last chapter, we learned that the side across from the 90-degree angle is always called the hypotenuse. All right. Now, if you see this funny looking symbol down here, this is a symbol basically saying that this is the angle we're working with. Okay, it's just another fancy way of saying this is what we're working with. Now we have to look at the other two words. We have adjacent and opposite. Well, now we look at this particular angle and we say, okay, which side of the triangle is adjacent to this angle and which one is opposite? All right, if you guessed that this one would be opposite, you're correct. If you thought this one would be adjacent, you're also correct. Okay, so let's just look at this one. So right away, we know we have the hypotenuse. The angle I'm looking at is right here. So then I'm going to think, okay, what's next to it or adjacent to it? It's up here. And last but not least, opposite. All right, so what I'd like you to do is draw this triangle and correctly label the hypotenuse, adjacent, and opposite sides of this last light blue triangle in your whisk tonight. All right, now with those sides and those names in mind, we actually have something, different things called sine, cosine, and tangent. All right, and those are spelled, just type them out for you, sine, oops, cosine, tangent. All right, and sine is abbreviated as SIN, cosine is COS, tangent is TAN. All right, and there's this really cool acronym to actually help you remember the ratios for each side, okay? It's SOHCAHTOA, and that's how you would say it, SOHCAHTOA. And this is a widely used acronym for this. What this means is we have sine, opposite over hypotenuse, just like it's shown here. Cosine, adjacent over hypotenuse, right here. And tangent, opposite over adjacent. All right, and they're all written out right here. Okay, so in this case, when we look at my triangle down here, I'm looking at my x angle, and I'm saying, okay, well, I have the sine would be the opposite over my hypotenuse, so A over B. My cosine would be adjacent, C over hypotenuse, B. And then my tangent would be opposite over adjacent, so A over C. Okay? SOHCAHTOA. Memorize it. Commit it to your memory. It will come up again, especially when you are in trigonometry in high school. All right, so find the ratios. Remember to correctly name the segments. So we have this um, triangle here, ABC. It's a right triangle. We know this because it has the 90-degree symbol in the corner. And what they're asking you to do here is name the segments of the ratios that are sine of angle C. So in this case, we're talking about that angle right here. So sine, if you remember, so opposite over adjacent, so opposite over um, oh, sorry, opposite over hypotenuse, my mistake, it would be AB over AC. All right. So with that in mind, what I'd like you to do is do these next two. Draw this triangle out and find the tangent of angle C and the sine of angle A. Okay? All right. Do this in your whisk, okay? All right. The next, what we're going to do is it says write the ratio in fractions. So here we actually have numbers. So my tangent of my angle would be the opposite over adjacent, so 36 over 15. Okay. Next, cosine would be, if you think about, so ka, A-H, so adjacent 15 over hypotenuse, so that would be 15 over 39. And sine, that would be the so that would be opposite over hypotenuse, 36 over 39. All right, so we have 36 over 15, 15 over 39, 36 over 39. Okay. Now we can actually write these as decimals, and that's often how it's going to look in your, if you were to plug this into the calculator. Okay. So from here, these are just consecutively in order what these ratios would look like as decimals. All right, now how to actually solve these. What we can actually do is we can actually find the ratios as a decimal by plugging some information into the calculator. All right, I'm sure that on your scientific calculator you have seen those buttons that look like tan, sine, and cos. This is where you're going to do it. If you look at your calculator, you could press tan and then 48 degrees. That'll pop out a decimal, and that's actually the ratio in a decimal form. You can type in sine, push sine, and then type in 48, and it'll pop out another decimal, and cosine, it'll pop out another one. All right, so for example, let's do a couple of these. I brought a scientific calculator up on Google. Okay, so what I can do is I can hit my tangent of 48, close my parentheses, equal, I have 1.2, we can just round it there, okay? All right, so if you have any questions, please let me know. This should be pretty self-explanatory with just using the calculator, okay? All right, so we can use these, this is our last example for the day, we can use these ideas to actually find out some information. All right, so we know that anything is going to be, for example, if I do tangent of an angle, let's say we're using this example here, 32 degrees, my ratio is going to be the opposite over the adjacent fraction. All right, now what we can do is with this idea in mind, we can actually solve for one of these. We can solve for the opposite or the adjacent depending on what information we have. Same with sine, same with cosine, exact same idea. So let's read through this question. It says, you can find the missing side of a triangle if you know one side and one acute angle. So we know one side, the side is 125 feet, and we know one angle, 32 feet. Okay? And this triangle is creating a 90-degree angle. All right, so first of all, right away we should say, well, this is my hypotenuse. All right, of the 32, this is my opposite. and this is my adjacent. All right. Now it says, how tall is the tree to the nearest foot? So I want to figure out my opposite, or my O, okay? So first, determine what ratio to use. Well, in this problem, you have the adjacent, and you are looking for the opposite. So what ratio should you use? Your mind should immediately go to tangent. All right. So right away, look at how I set up my problem here. I have tangent of 32 equals x, which is my O in this case, my unknown, over 125, my opposite over my adjacent. Okay, from here I have to write the ratio as an equation and solve. So from here I actually can figure out what tangent of 32 is. Well, it's 0.625. And then I can actually create a, a cross multiplying situation, or a proportion. And I know I just flashed you the answer, but that's okay. And from here I could say, well, I have to just cross multiply. So in this case, 1x times 0.65 times 125. It's about 78 feet tall. All right, so tomorrow we're going to be working on this quite a bit, and please make sure that you memorize this idea here, and you'll do fine. All right, thanks guys.